Again, this is Dr. Satish Singhal, PhD, El Camino College, Torrance, California, Professor of Computer Science. Please watch my video 1, part 1 before watching this. Otherwise, you might see some disconnect. We'll try to put a playlist for the videos that should be watched in a sequence. I'm going to talk about user-defined functions in C part 2. I'm going to show you some stuff in compiler now. So let's go to compiler. Imagine that you want to square a number and there's no function in math.h library that does that. Of course, you can see that's a calculator level problem, but we're taking a simple example first in order to demo how functions, user-defined functions are written. And if you would remember from part 1 that user-defined functions are written this way, the one that are value returning. You have data type that is to be returned, function name, argument list. Value is used, these arguments are used through an algorithm here to compute a value, and compute a value is returned by using a return statement, which is a C keyword. This has to be same data type as that. Ultimately, arguments may be different data type, doesn't matter, but computed value should be same data type as this one, and after return statement, this computed value is returned to the caller. Okay, and so we're gonna write a square function. So let's, for the time being, okay, we will have it a double type because we may want to do a square of double number or int number. Now, after designing the return type, which I'm saying is a double type because I may want to get a square of double number or integer number. Next, very important decision is to decide function name. And don't take that very lightly. Don't take that decision very lightly. In software corporations, there are huge fights about what to name a function. Because once you name a function, it cannot be changed. You're tied to it permanently forever. And this being tied up to function name is so amazing, you would be shocked. For example, you use POW function, POW, 3 letters in the name. This was used way back somewhere, maybe in Algol 60, a very old language, and no one could change it. No one had the courage to change it to power even, POWER. Because if you rename functions to do certain things in your programming language, trust me, your programming language will die overnight. Nobody wants to remember new names. Okay, so name choice is extremely important. If you design a programming language, your programming language will live or die based on names of the functions in its library. So do not take names lightly. So in this case, square function is aptly named head square, or SQ if you want, SQR. You will also notice that old names are very short, POW, SQRT, things like that. Why? Because that's from the punch card days. Each program statement was a punch card. People didn't want to type too much on those noisy machines. That's why names are short. These days you can choose longer names, not a problem. So we want to square a double number. Double number is num. and return type, name, argument list, in this case only one argument, body of the function now, and just to show you, give you more details about mechanism of function calls, I'm going to create a temporary variable, double temp, and I will say this is num into num, and then return temp. So notice one property of functions we mentioned, that take an argument used in the algorithm. This is the computational algorithm. There's a return statement, temp is return. Okay, how is it used in the main function? We'll define a value data, no, double first, and that, let's say it is 2 point, we want to keep it very close to 2 because we know square of 2 which is 4, and then we will take the square value, double sqr, well, call the function now on the right hand side. Value returning functions are always on the right hand side of an assignment expression, data, and we'll just print it. So we'll say printf we can say, basically we can kind of output as a mathematical expression, data to the power 2 okay, I'm sorry, if you want to be data, we'll have to put a percent lf, and this will be our first argument will be data equals another percent lf, and that argument will be sqr value, or well, and slash n to the end of the line. So that's that. Now if we run this program right now, I don't see any red sign, so it's compilable. Then you will see that 2.001 to the power 2 equals whatever the result will be square well. Okay, so let's just run it first. And that's our result, 2.01000 to the power 2 equal to 4.004001, and that sounds reasonable. Okay, now one thing I want to, as I said in part 1 video, when this line is executed, temporarily control of program shifts to this function, and then this algorithm is computed value is returned, function call comes back to this line again, computed value is stored here, and then as you saw we were able to print it, 4.04001. Okay, now let's see that in the compiler. We'll put a break point here and we'll run it now. So compiler start with this line, we will go through this line, and notice the value of data is, it's not going to show 2.001 because 001 is approximated value. It's going to show something different, slightly different, but very close to it. Now, this right hand side has to be done first in the assignment when you use assignment operator. If I click here, it will show us that control transfer to function. There you go. Control transfer to function. And notice that at this time, data has a value of 2.001. Num will also have value of 2.001. That means while this function call is taking place, we have two copies of same value. Data here in the main function and num in the square function. This kind of mechanism is called pass by value, because what we have done is we didn't take this memory location and pass it to square function. We just copied value stored here into value stored here. That's why they don't have to have same name. Can have same name, but can have different name also. So what I'm saying is these are two different variables. This has a different address than this, but they do have the same value. That mechanism is called pass by value mechanism. We mentioned that a little bit before, but here's the detail. Now, if we continue on, temp is computed, which is slightly more than 4. In fact, you can put your mouse there. You can put your, this is 2.001, square of that is 4.004, and that is computed, and that's returned. If I continue on, I'll come back to the main function, same line where before I transfer to this one, and the right hand side will be completed. See? And right now square val has 0 means actually it's undefined value, but as soon as I do one more line, square val got the same value that temp had here earlier, and function call is complete. So most important point we wanted to make was that during function call, control is transferred to the function that was called with the data being copied to the argument of the function. Two pieces of data here, num there, having same value, but two separate memory location. And now, of course, if we complete the process, we got our output shown by printf. Okay? All right. So one thing that I said is that memory location of data is different from num, only the values are same. Can we illustrate that? Certainly we can. We can print the address of data here in main function and address of num here, and you'll see there are different addresses. So let's do that using printf. Address of data in main function. And address is printed by using ampersand sign. Okay. And then we can take the same line and put that here to print the address of num. Num in square function. Num. Okay. Okay, we will try. It's kind of objecting to this, but we'll see. We'll see what happens. I think it should work actually. So let's try it. If it doesn't work, we'll do something different. Actually, it did work. So address of data in main function is this number 160.641.6080, but address of square in main in the other function, address of num in a square function is 160.41.6040. So that does prove that this num and this data are different variables in the RAM. Of course, num gets destroyed as soon as this function is finished, but during function call, two different variables contain identical value. That's why it's called pass by value mechanism. Okay, that's part one. Now we'll comment it out for the time being because we don't need it. Okay, this will go away. If I run it one more time, it'll go away. Okay. Xcode sometimes sticks to things, but don't just ignore that. Okay. All right. Now let's say I wanted to write a cube function, and now I want to. In a minute, I'll come to the topic of function prototype. Well, I mean, cube is that you multiply the number by itself 3 times. But hey, I've done square already. Functions can call each other. So I can write cube function this way. Double cube is a good name. Double and let's say value. One way to do that would be, we'll say double temp equal to value into value into value. You can certainly do that, not a problem. But notice we have already done the square, so why not use to compute the square here and then multiply by value so that I can use this existing software already that is there. Well, certainly I could do that. Typing that and pass the value to it. And then return the stamp. Okay, so now I can call the cube function also in the main and print the cube of data. So I can do this, double cube val equal to, call the cube function now, pass the data, and then I can print that value also. Okay, I'm doing one thing here that is a little different, declaring the data type as I go along. Xcode accepts that, some compiler may not, so you may have to do this in some other compilers that declare it here like that, take off that, and then declare here like that. Yeah, Xcode is very C++ style. Yeah, so, and then take off that. So in some compiler you may actually have to do that. Okay, now we'll print the cube value. So print that. and that's a cube of data, and that will be cube val. Okay, this will work also, but in a slightly different way. 2.01 will be copied here first, then will be passed to the square, and then control will be taken by the square. 2.01 will be passed here, square will be done. That square value 4.004, something like that, will be placed here, and then 2.01 will be multiplied. Compute result is temp, will return the temp. Okay, that's how it's going to work. As far as function working is concerned, uh, redefinition of qval. No, I didn't do that. Yeah, these error messages take a while to disappear, but it'll work. Okay. Yeah. So it does work. First I get the square of the 2.001, then I get its cube. Okay. Now that's great. I was able to write one function, call it from another one. Both could be called from the main. So functions can call each other. That's established. User-defined functions can call each other, and they can be called from the main. Okay, we know that. So now I just want to do one little thing, and you'll be very surprised by that. Imagine I change the order of function definition. Place cube here instead of after square. And now if I run it, build fail, I get the 2 compile error, and really don't pay any attention. These are too cryptic. But basically what it is saying is that when it comes to this definition here, it is saying, hey, I can't find a square function, although it's right here. But the rule in C is that anything that is used has to be defined first. If I read from line 6, 7, 8, 9 up to line 8, there is no discussion of square function at all. Okay, so compiler can't find it, we end up getting the compile error. Okay, let me see if I can ignore this hide issue. Okay, didn't hide it. Okay, we'll have to live with this for a while. And again, this conflicting type is, I'm not sure what that is. But basically this is important. Here it says, hey, I can't find it. Now, in small number functions, you can rearrange them the way I had it earlier, like undo paste, and it'll work fine. Okay, it works fine. Succeeded. Here's our result. But let's say you had 100 functions in a program, you'll be very hard pressed to arrange them in a way that function that is called is defined in order of sequence before the function that calls it. Called must be defined before its caller. That's the rule. But if you have hundreds of functions, that would be very hard to do. So C has a technology called function prototypes. If I did it this way, and again I have compiler error now. Okay, build fail, can't run it. So C has a technology called function prototypes. This is very important technology, and this is very important to understand it. What function prototype is that we take the header line and copy and paste it before and put a semicolon. That's the prototype for Q function. And we'll do the same thing, prototype for square function. Put that here. Prototype for square function. So prototype is simply the header line terminated by semicolon. Now you'll see that all of a sudden this will work. Okay, it says build fail. Okay, yeah, I think I have 2 cubes here, so let me just delete this one. Sorry about that. I just need 1 cube. This will work now. Okay, it works now. All right. The reason it worked is that inside the cube we use square, although square is defined after that. But this prototype is a promise to the compiler that we are going to have definition of this function somewhere after in this file, in this entire file. So please don't give us a compile error until you find that definition. If you don't find that definition, that would still not be compile error. There will be linker error. Linker at runtime will fail to link to this function. But whole idea of prototype is not to get a compile error until entire file has been read. And promise is that function definition will be there in the file somewhere. So notice I can put the definitions here, or I can take them out of here and even put them after the main, which is usually the pattern, and it will still work. Notice they're being used, being called in the main. Square is being called from the cube here. Now function definitions can be written in any order because we have prototype of the function that is promised to the compiler that in this file we'll define these functions somewhere. Please don't give us a compiler error until you have read the whole file. Now I want to emphasize this very much. Prototypes are required or always required. Do not skip them. Now I have to talk like a professor. Points will be taken off if prototypes are skipped. They are part of the software industry that cannot be ignored. Okay, prototypes are always required. You do have some flexibility in writing prototype, like if I take off the data type, if I take the name off, it'll still work. See, still works. So I could do that if I wanted to, but usually a variable name is needed for documentation, so it's better to just have them actually. Okay, today's industry standard, kind of, for documentation it's required. Okay, so in this video I've discussed how value returning functions are defined, how control shifts the function when function is called, how computed value is returned after return statement, how computed value is stored in the left hand side variable left of assignment operator, how function call is made of the value returning functions where there is an assignment operator always present in call to value returning function, how prototypes are always required. That's a software industry rule, you cannot skip that. Okay, always required. It doesn't matter in which order you write them. All the function prototype of all the functions except main must be listed after the number include statements. And you can write after that functions can be written in any order. Usually, of course, main is first and user defined functions are put after that. Okay, in value returning, in parameter passing by value, like square was passed to square here, during the call to square function, you have two variables with the same value but different memory address. We demoed that earlier. Okay, so let's just write a print void function also, just to illustrate void. And we'll just do a void print. Let's see what I want to do. I want to print both data and its value at the same time. So I'll take two double value double powered value. It could be square or cube. Okay, now I'm going to write definition of that. Notice I use the print because print is a good name. I didn't call it zoo or anything. So you have to keep function name that will become popular with people, popular with the user. Okay. um, okay, I should pass three parameters because it needs to know what power we did. Int n. That will be a little bit more useful. And now I can do a printf statement just like this one, although it will be modified just a little bit. And it will be %lf, another %d. So here will be value, then n, and then power value. Okay, there is an extra comma. Okay, and now I can just replace these printf with this print statement. So I'm just gonna take this off. So first one was value itself, which was data. Second argument was n. We squared by 2, we did the square, so it's 2, and powered value is SQ or val. That's first call to the print function, and we don't need this because we have void print function. This time it will be 3, and it will be cube val. So value returning function square will compute the square, store in this one. Void function print. Notice the call syntax. There's no equal sign in void function call. No equal sign in the void function call. Equal sign in the value returning function. Equal sign in the value returning function. A lot of students forget that. This is very, very important. Okay. Value returning function should have an assignment operator, value being stored in the left hand side operator. Okay, so this is not going to be very magical. Output will be simply this. In fact, if you keep your eyes here, you'll see this will not budge. And we got the same output back. Okay, no, there is an error. 4. Why is it 4? I don't. Okay, actually I messed up. Did I mess up in the argument? Okay, number to the power n. Yeah, this I don't understand what happened. No. Oh yeah, okay, I messed up here. Okay, I'm gonna have to resolve. Let me see. So we got the data. Data is correct in both. Two. Okay, I have to debug it now. So let's put a breakpoint here. Go. All right. So okay, I'll debug it here. Jump into the function. Okay, go into the function. Oh, it didn't go into the function. Okay, let's start again. Sorry that this video is going to get a little longer. Okay. So data here is 2.0. This is 2. So the question is, why didn't I get 2? This is 4. So those are correct values. So now go into the function. This is that. This is powered value. Oh, okay. I messed up in the arguments here. Okay, now I see it. Yeah. So square val comes before, n comes after that. Okay, that's what happened. So be very careful that arguments are passed in the same order in which they are being used. See, I messed up and I paid the price. So now it will come out exactly. Okay, so let me delete my breakpoint and do it again. Yeah, now it's correct. See, 2.01 to the power 2 is 4, 2.01 to the power 3. So what I messed up was I passed the argument in the wrong order. See, this should be the powered value and this should be the value it was powered to, but I had reversed them. I put that here and that's going to mess up everything. So we'll learn a valuable lesson that argument order here should be same as argument order here, or the reverse. Argument order here should be same as this one. You cannot shift argument around that I did, and I got some crazy results because of that. So sometimes making error is a good way to illustrate a point. I did not plan on making an error, but it turned out fine. So when function accepts more than one argument, then order of argument value should be same as order in the function header. That cannot be changed. Okay. So this is the illustration of the void function, value returning and the void function. In both cases, the values are being passed by copy mechanism. When I'm calling print function here, I'm copying data into value, cube value into power value, and 3 into n. And those are being used here. Notice void function does not have return statement, but value returning does call mechanism. Value returning has a assignment operator, void function, no assignment operator. Called to call the side effect. Side effect in this case is printing the value. Okay. All right, that's the part 2 of user-defined functions in C. We have illustrated function prototypes in this video and demo of void functions, and of course how function takes the control when it is called and uses the parameters to execute certain algorithm inside it. Okay, goodbye from part 2. We're going to do, in part 3, we're going to talk about pointers, use of pointers, because there is another mechanism of passing parameter to functions through passing address of a variable, which is done through pointers. We cannot learn that mechanism without learning something about pointers. So part 3 will be on pointers, and part 4 will be how to pass parameters through a pointer through an address. That's the future plan. Goodbye.